statistical and machine learning modeling in climate sciences, especially subseasonal to seasonal forecasting. He is also at present working in the University of Colorado Research as a scientist, three working with NOAA Earth System Research Laboratories, Physical Science Laboratory. Previously, he has held influential position at the Department of Meteorology and Atmospheric Sciences at Pennsylvania State University, the International Research Institute for Climate and Society at Columbia University, the Institute for Sustainable Cities at City University of New York, the National Center for Medium Range Weather Forecasting in India, the Indian Institute of Technology, Delhi, and Bhubaneswar. He is actively engaged in several regional climate outlook forums by WMO as an expert and trainer of S2S forecast and verification. So, from his credential, you understand that how much he has the potential nationally and internationally, and he has a lot of exposures. We are very sure that today's deliberation from Nachiketa will be a kind of stepping stone for a much needed S2S forecast and subseasonal forecast, which this particular this South Asia and other parts of the world they need because of the ongoing climate variability and projected climate change. So I'll stop it here now. The floor is with Nachiketa. So I am warmly inviting Nachiketa to give his presentation. Over to Nachiketa.
Thank you, Namaste, sir. And sorry, I was a little late because I was
No issue.
kind of overestimate the time.
No
So
issue.
first of all, I congratulate Safam, especially you, because this is an excellent forum, and it's just not like just a forum to say. It's like a lot of activity going on, and really thanks to giving me this opportunity to share my experience. So I start with sharing my screen, and please let me know if you can see in a presentation mode in my slides. Is it visible?
Yeah, it's visible. Yeah.
Okay. So yeah, so I'll not take a lot of time today, but just to share my experience as a forecaster, as working with the stakeholders, the application of subseasonal to seasonal scale. But before that, I just want to say a little more from my background. Although Dr. Chattopadhyay said a huge introduction, but I can say myself as a climate data scientist. That is by a happy chance or by luck, you can say. So uh, I was a fresh master's in statistics. I was looking for a job, and then I ended up with Professor Mohanty's lab, who is also part of this today's webinar, and he kindly gave me this opportunity and take a risk on me to just work on a pure statistical approach in a climate data. And throughout the year, I was kind of learning a lot from the field, from my teachers, colleagues, collaborators, and a lot of students. So I try to be more, using climate lingo than the, data science lingo. So I'm still learning. So just let you know, I'm not an expert. I'm still learning my process. But while I'm learning, I take an approach called research to operation to research. And that is also thanks to Dr. Mohanty because he did not give me an academic problem to solve during my PhD. Rather, he put me a project, which is a very famous project back in India. It's called Extended Range Forecast System, where we are funded by Department of Agriculture, Extension Government of India, where we try to like try to explore whether we can predict a subseasonal forecast. But back then, in 2005 or six, we call it extended range forecast. So that's what I always work with a different, approach. The first thing, a very core prediction researcher working on AI/ML statistics, extreme value, a lot of academic research. I also making an operational forecast. Started from my PhD. Then I was working on National Center for Medium Range Forecast. Then I was a part of Columbia University IRI. Right now in NOAA, so doing a lot of operational forecasting. At the same time, I also do a lot of capacity building because capacity building is like a key on this R2O2R approach because it's not only capacity building to the forecaster, it's also capacity building to the stakeholders to understand that what they got and how to interpret. And obviously, working with stakeholders give me an immense opportunity to improve my forecasting methodology, the products, and so much so on. So that's kind of approach I took. On that, I start with giving you some kind of a caution what I'm talking about. So today we talk about seasonal to sub-seasonal. So when I say caution, that means we should know the limitations of the forecast, and we also know like where the forecast skill comes. So if you think about uh, a time scale where it starts from nowcasting, like 6 hour thunderstorm forecast to a decadal climate change prediction. So seasonal and sub-seasonal is somewhere in the between. And most of the cases, the seasonal forecast predictability comes from the boundary forcing, or we call the sea surface temperature. And this too is very popular, well-known features of tropical Pacific is El Nino and La Nino. We all kind of know the impact. So that's kind of a predictability opportunity. Wherever we have kind of strong La Nina or El Nino, we are more confident. And we can see right now, after the triple La Nina years, we are moving to the El Nino. And another hardest is like sub-seasonal, which is I can say like more hardest than the seasonal. Because seasonal focus based on the kind of boundary forcing. Sub-seasonal is mixture because it's a bridge between the short range forecast, which is day 1 to day 10, you can say, and the seasonal forecast, which is hardly get. And the skill comes mostly from different circulation. One of them is very popular called middle Julian oscillation. I'm not going to explain this, hardcore thing, but just let you know, like, it's not a magic to give the forecast. The forecast has a background of science, which is come from the meteorology. Now, the expected scale, as you all know, after 5 days, there is no scale. But this is joke apart. It's like maybe 50 years back cartoon. But this is the kind of a state of art. And I want to show you this two line, the seasonal and sub-seasonal. You can see the scale, which is a very like subjective map, but you can see the skill is kind of a fair to poor. It's not like an excellent skill, and we are talking about the application of this forecast. So we need to know like the limitation of the forecast skill, and based on that, we need to kind of make this contingency plan for the application. On that note, I can start today's discussion. So I was thinking about this talk, and I was thinking about how I can present this talk in terms of application. And I took two examples of my research. One of them is working with Bangladesh Department of Agriculture, World Fish, BMD, Bangladesh Meteorological Department, CIMIT, Bangladesh, where we kind of try to making an early warning system based on a seasonal forecast for the aquaculture. So that is like the first part of my talk. And the second part of my talk will be more on Indian scenario where we try to make a sub-seasonal forecast based agro advisories. So I'll come later. I start with this. And obviously, I thanks all my co-authors on that. So this is kind of all known that the agriculture in Bangladesh and how it increased the production last 20 years. I don't need to say, just for the context, I put it here. But the main objective of that particular research, we want to develop a seasonal early warning system for high temperature and intense precipitation, which assists the pond aquaculture. And this work is actually like when I joined this project, is already the project already started with the World Fish program from Bangladesh, and they are kind of having a pilot study for different part of Bangladesh and having a lot of ground data. So this is the paper they mention about these two pilot study. One is Khulna and one is Sylhet, and like they have like a huge hectare area of agriculture for both the places. And Sylhet, the main fishes they actually cultivate is tilapia, koi, carp, and katla. And for the Khulna, it's mostly shrimp. So when I joined this project and they are talking about like, okay, so we got a lot of data and how to use that data and how to use your seasonal focus to make some kind of a proof of concept so that we can actually work like more in the future. So that all the project we started is a very proof of concept. It's not like a finished product, but it may be an example for way forward. So the pond temperature data we like they collected from 1 year, which is 2018 2019, And other data we actually use from ground rainfall and temperature from Bangladesh Met Department. And for the seasonal forecast, I use different kind of general circulation model, and those are mostly based on North American multi-model ensemble projects, where I was part of that from the NOAA side. So I use all those, state-of-art physics-based dynamical model output, and we use that 1991 to 2016, that period, to make our experiment. So first we need to think about the impact of maximum temperature. So in a seasonal forecast, we only produce the seasonal mean temperature. We are not producing a pond temperature. So we need to find some kind of a bridge between a pond temperature and the seasonal temperature. So we first started thinking about talking about all the agriculture expert to know like what is the temperature sensitivity of those fishes, mostly rohu and tiger shrimp. And we found that they can sustain a water temperature of 30 degrees Celsius, while tilapia fish can tolerate up to 32 degrees Celsius. And physiological stress condition occur when the temperature exceed those values. So that means like if we found a number of warm days which is greater than T max 32 degrees Celsius, this information can be a good uh, information to the aquaculture specialists so that they can make their plan. For the rainfall, the same thing we found, and we found some kind of range, and like 44 millimeter precipitation per day is something our threshold to something to predict. So from the local data and talking with the experts, we kind of get those numbers. Once we get the numbers, we try to make the relationship between those numbers and the seasonal mean temperature and rainfall. And we use a very empirical relationship. So the number of warm days versus mean May, June, July, and August, September, October, these two seasons for Sylhet and Khulna, we try to make some kind of a linear fit between those days and seasonal mean, because in a seasonal forecast, we are only predicting seasonal mean and temperature and rainfall, so we cannot predict the number of days. So that's how we make some kind of relationship between those two statistics. Once we have everything in our information data sheet, we start making the actual seasonal forecast, and we use the lead one. Lead one means like we make the forecast in April for May to July. You can say that whether the lead one is sufficient to make any application. Yes, it's not sufficient, but we also need to think about the limitation of predictability. That's what I start with all those cautions. We cannot go like, ideally somebody wants to know this information 6 months ahead, but it's not possible to make a skillful forecast. So to just make this proof of concept, we start with very highly skillful time period, which is lead one for both the season. And you all know, like, there's a lot of biases in climate model. It's not like you straightforward use that raw. So we use a standardized reconstruction method, which like kind of developed during my PhD time. So we use the same thing with respect to BMD station data. So we replace the bias corrected GCM output in a linear models, and it looked like now we can see like so we try to predict number of days where the temperature is greater than 32 degrees Celsius. That's something we want to predict. We have back from here, we have this relationship from the observed seasonal mean temperature. Now we replace that with the forecasted GCM and use the same linear method to predict the number of days. So that's the way we try to predict in real time. So we first make an empirical relationship based on the historical data, and then we replace the historical data with bias corrected GCM. And here we try to find the skill of individual GCM rather than a multimodal ensemble system or a final focused, because we need to know like how the GCM reacts. While doing this, we do a lot of statistical skill score calculation with a lot of different things, and we found a kind of heat map with different season versus different areas, Sylhet and Khunla, for different statistics, which is number of rainy days, number of wet days. So kind of a lot of combination. We also try to find the MME scale, and we found one of the models is really good, so we can actually use that. And we try to write this thing in a paper, Journal of Climate Services, to to know whether whatever we do is like in the right way or not. And we got a lot of good review. So we thought like this is the proof of concept so that climate model in seasonal scale can be useful for making early warning system. But how to make a real-time prediction? And for real-time prediction, we need a real-time multi-model ensemble, which is a combination of all the climate model, because we don't know in a real time which model is good and bad. So that will be like way forward. And that's what we thought that time, that we may use the BMD's next generation forecast. And we can also use, instead of two different district, we can make it for all different districts using a gridded data. And maybe we can add more relevant variables of interest. So that's something we work on the application. Now, thinking about what is BMD's next generation forecast. So I go back a little history and let you know like how BMD make the seasonal forecast, how it used to be and how it is right now. And I'm fortunate to part of this whole development since 2017 with the scientists from BMD like Kamrul and Bajru and others and Manan. So when I start working with them, and I found like they have like a one pager seasonal forecast. It's mostly text about what happened last season and what expected for whole country as a whole, which is not so helpful. And working with DAE Bangladesh, especially Dr. Majar, we understand that it's not something the DAE wants. So on that time, I was working with the USAID project with CIMIT and try to find some new objective-based forecast. And as a part of WMO seasonal forecast expert team, I also thinking about use the WMO's guidelines to make this forecast instead of just a research product. So working with BMD a couple of years, we developed a system called Next Generation Forecast, which is online since October 2019, and you can actually see it in real time. Go to BMD's website, you can find the next gen. And here, this is the one example map where you can actually get the spatial map of total rainfall, or sorry, average rainfall for monthly and seasonal, and which is more kind of helpful in terms of thinking about the spatial heterogeneity of the monsoon or other season. It has also a lot of tailored products instead of just total rainfall. You can just calculate the dominant tertiary probability, probability accidents, non-accident, a lot of things. So that was the work when I was part of IRI and we work with that. So telling this thing, that means suppose we have this kind of very advanced forecast system, and we already have a proof of concept with GCMs, and we found there's some kind of scope. So we can actually combine this next generation seasonal forecast with our model, which is developed for aquaculture, to make a real-time, more skillful, objective-based forecast system. So that's something on the seasonal focus thing. So now let's change the gear and thinking about sub-seasonal. Yes, and this is another project. Is like we started work with Bihar community, like farming community at Bihar, and I would try to I want to thanks to my colleagues back in IRI and then Indian Meteorological Department, IITM, RIMES, University of Arizona, CIMIT, and all the NGOs, and especially with the farmers. And that's something, this project is very close to my heart because this is the first time I really visited the village. I talk with the farmers. I see how they actually farm. I was kind of traveling across the Bihar on like in 1 month time period. Literally, it was a really amazing learning experience. So first of all, I just want to tell like what are the project and who is funded. So this project funded by NOAA, and NOAA has a wing called International Research and Application. It's called IRAP, and IRAP is not only working on India, it's like everywhere in the Caribbean, in Bangladesh, in India, in so many different places. Now the question is why we choose Bihar, and that was a very good question. Like when somebody asked me like why you are showing everything for Bihar. So first of all, Bihar is a very interesting state with a very interesting climatic phenomena. It has a flood-prone area in the north, and it has a drought-prone area in the south. And those flood is not actually only for the rainfall. We all know like the Koshi River and the management of Indian government and Nepal government. Like almost every season, you can experience a flood over northern part of Bihar. At the same time, you can also experience the drought over the southern part of Bihar. So that is very interesting in terms of research. We choose it. Also, there is a valid connection with the GBCAR project, which is funded by government of Bihar, and from as our partner was University of Arizona, and one of them is actually working with the World Bank with this project, and they said like GBCAR has all the component except the climate component. Why not we kind of complement that climate component from this project? So we became a part of GBCAR project while working on that, and. So it has like a lot of goals, and before even start any research there's a lot of surveys, like literally like we spent like 1.5 years to get all the information. It's not only based on climate data, it's also based on livelihood data and how they get the information. So and that is I'm talking about in 2015 2016, that the time period this surveys. So, and we was thinking about how to complement this the utilization of climate information with Jivika, whatever. So we have a baseline data. We hire a company local, and they go to the 25 household per village, almost 6,600 households, and they kind of go a community level survey. And you know there's a lot of problem with those data. As you all know, the survey data is not like a to believe. We do a lot of post processing of the data, a lot of validation check, and we also hire a different company who can actually validate those data. So a lot of different things, but we kind of distribute this whole survey in a flood prone and drought prone districts: flood from Darbhanga, East Champaran, and drought for Noida and Jahanabad. And it got almost 132 village, actually 66 each. So I want to show one example of the survey. So one of the things I really like they want to ask like whether you like to receive the like climate or weather forecast from the next crop season, and everybody almost say yes, we want that. And there's like what kind of desired forecast you want: next few days, next week, 2 weeks, month, and seasonal. So most of the cases, like except the Noida and Jehanabad, they kind of doesn't understand the seasonal forecast, how to like use the seasonal forecast in day-to-day farming. But there's a lot of interest on to know what if, like what is after 5 days, because while I'm visiting the village and I see like almost everybody got that text message from IMD for next 5 days. So they are kind of very well aware about the forecast for next 5 days and the advisory based on agromet department, Pune. But they want to know what happened after 2 weeks. And I'm talking about this is again 2017-ish. That the time IMD also thinking about whether they go for a subseasonal focus. So that the time IMD doesn't have district level subseasonal focused. So we really got that data, and IMD is a part of this project. So Dr. KK Singh, Dr. Sahai was a part, Dr. Kripan Ghosh. Like we are actually moving all around Bihar and get those information. That is also very helpful for the IMD at that time. So just to know the scope, whether we got all the data, okay, and we promise that we give the forecast, but we need to validate ourselves. We need to convince ourselves because we know the skill is so bad. So whether it's possible or not, that's important. So we do a lot of background academic research, and this is one of the snapshot of that. So this is one of rainfall anomaly plot. Anything in green is more than the climatology, and anything is gray is less. So I took this example from 13 to 19 July. That's 7 days time period in 2013, and this is like IMD's data. Sorry, this is CHIPS data, which is equivalent to IMD's data, but using satellite data over the ocean. And we are looking at the best model in the world right now, which is ECMWF, to see whether we can capture those kind of breaks in week 4. And you can see that week 1, week 2, week 3, week 4, these are like different lead time of the forecast. And we get some kind of signal. Maybe it's very different in terms of magnitude. Maybe it's minus 60 anomaly, but in a forecast it's just like minus 20 or minus 10. But still, in time of week 4, it gives that signal, and that's kind of a hope, and that's kind of our confidence. Like okay, so the magnitude may be different. We can correct it by bias correction, but the important thing is to capture the signal. So based on that background research, we kind of confident to move forward and making those things. And as I said, like we can make that magnitude correct by bias correction. So we don't like we need to have some kind of post processing of the forecast. And there's like a one conceptual, like suppose the red line is the observed rainfall for a particular region, and we give a forecast which is look like very straight line, and there's a lot of bias, amplitude bias, and also the correlation bias. You can see there is some variability in the blue line, but not exactly like the red line. So there is a lot of scope if you have a lot of data and computational power, and if you know the exact statistical or machine learning method, you can cover that part. And we kind of use a method called canonical correlation analysis. Again, it's a lot of technical discussion. I don't want to go there, but the whole point is like instead of using the local information from the climate model, we use a bigger domain so that we can actually cover the spatial error, and then we downscale that seasonal forecast to a particular domain and giving all the information to the neighborhood grids. So we use that method on CFS version 2, which is NOAA's model for subseasonal. And back then, IITM is also started running their own version of IITM slash IMD CFS2. So we thought like, let's use that model because this is the model IMD going to be used in real time. And that's what right now actually. So just to know like, the hindcast skill generation. So before going to give our forecast, we always test our forecast in a past, like past events. In our lingo, we call hindcast or past forecast, and to just to know like what is the scale in different week. And we found like week one has a really good scale, and as we know, week one is the actually the skill come from the weather forecast, which is on the persistent. So we are not so much happy on that. We know that there will be skill, but we are kind of interested on what if after week one, what is the week two, or mostly week 3 plus 4. And as I already mentioned, the skill is not so good, but it has some moderate one. So we started with that. And we also thinking about, okay, so how about maybe we get the skill by chance because we just playing with the domain of this bias correction. Let's see the bigger picture. So we kind of do the same experiment for the bigger picture to know whether the skill is you know, robust or by chance. And we found it's kind of robust if you look the bigger picture of the, that predicted domain. Now coming to the operational, like experimental operational system. So in 2018, we started making it a real time. So we start making two different forecasts. One is subseasonal forecast, one is seasonal forecast. So I'm mostly showing here the subseasonal forecast. So there is like we started making this forecast from June 7 to September 27, which has 17 weekly forecast. So we develop the forecast every week. We send that forecast to Dr. Patnaik, Dr. Sahai from IMD IITM side. And they also started that time their IITM IMD based CFS forecast. They give their feedback. Most of the cases we are in the same, same mindset that yes, this is the forecast we go. And once the forecast was prepared, we put it in a website. But as we all know, those website nobody's going to check. So we need to have a forecast summary. So we make a text message based on that forecast and send to the rhymes, which is our partner in the local, and then rhymes send those messages to the state agriculture universities. Now here I want to say, like during this time period 2015, 16, 17, 18, while you are making this forecast generation, we're also giving a lot of farm school training, and rhymes is a the part of that with all the two state agriculture university. One is in Bhagalpur and one is in Patna. So there's a lot of capacity building to the NGOs who are actually finally work with the farmer and also like prospective farmers, so that they understand what is three category forecast, what is normal, which is abnormal, what does it mean by probability of accidents, and how to look the confidence of the forecast. So we kind of teaching our stakeholder that what we are going to give and how they interpret on their practices. So on after that, when you start this operational forecast, we keep those for text messages to the state agriculture university, and they kind of translate it and they putting their added value. and finally it goes to the NGO, and finally NGO goes to the farmer. And this is the website we make, but this is like two example agro advisory based on local language, and this is like uh, during this whole monsoon 2018 period. And interesting thing is 2018 monsoon was a very different over Bihar. It has a very late start or late onset. And we, although like we mostly looking at the four district like Darbhanga, East Champaran, Nawada, and Janabad. So we kind of plotting this after the incident happened. We are kind of validate our forecast and looking at the. We also plot the Bihar average rainfall, which is black line here, and we found there's like 11 of the 18 weeks is actually deficit rainfall. So that was a very poor rainfall year in 2018, which is very interesting because we start this forecast in a operational mode and we are ended up with a very challenging monsoon. So we are very afraid, but and we try to be very honest. Like if the forecast doesn't work, doesn't work. We don't want to do anything after the season ahead. So that's what we do everything in a real time, and then we go to validate it. And also we validate in and as atmospheric scientists we also see like why it was so deficit, and we found the MJOs uh, the the position of the MJO such a way that is happen to be a very deficit rainfall over Bihar. And this is one example, a real-time forecast in June. It's issued at June for week one forecast, which is June 15 to 21, and week two, which is June 22 to 28. And why I'm showing this thing, because this is like mid of June, and you can see the forecast is like below normal. The anything in a yellowish is like below normal. So we get a strong below normal forecast, and we thought that means there will be late onset. And that exactly happened. Like when we plot this thing with the IMD data and plotting in a percentile wise, we found this week 15 to 21 and week 22 to 28 is like still there is no rainfall. In fact, the rainfall started, I remember it was like around 29 or 30th June. So it was a very late onset, and our forecast giving a very strong signal on that. And that based on that signal, the agro advisor is actually on that, like, don't start with the cropping. So this is kind of an example of how we make different forecasts for one particular district, like how we give the dominant probabilities and how the climatological probabilities. Kind of little technical, but the reason I want to show that I show this forecast skill in a past forecast. We also calculate the real-time skill score, which is challenging because real-time skill score doesn't have a lot of data. You have just one forecast for a week, but we try to calculate this whole sophisticated statistical skill score like Bright skill score, head skill score, to know like where is our gain or loss. But the real validation comes actually after the forecast. We have a lot of intervention meeting, and this is like one example of the intervention we started with. So in four pilot district, the University of Arizona Economic Department, they are part of us, and they make a econometric experiment. They thought about like just kind of regroup or subgroup whole prospective farmers. Like one group get only text message, one group get text message, and they also have learned the farm like FFS training, which is uh, I believe it's farm field school training, so that they got the text message, they also understand what is that. And then they also make a group like just sending only this forecast sorry, just yeah, only forecast. That's what the only text message. And another thing is like just a school, and another thing is just control. That means you have a control, doesn't receive anything. So based on their econometric experiment, they kind of like summarize the impact analysis. And this diagram shows that how the percentage change of the control, like how the farming strategy changes, where the people got only text message with the capacity building training, and only the capacity building training. So based on that, you can see that without capacity building training, people doesn't even understand. So it kind of 10% of they don't even care. But with capacity building, they use a lot. In fact, why, like the good thing is like if they doesn't have the focus, still they use that knowledge to change their farming strategy at least 41%. And the same thing, but I just want to summarize it, like almost half of the farmers that participated in the field school use that focus to change their farming. And farmer used the late arrival 2018 monsoon, almost 16 days, which was well captured in our focus. And they also changed to a less water demanding variety of paddy rice in response to expected a weaker monsoon. So that was like a pilot study. And after that, Rhymes and IMD keep on continue that project. And our pilot study has done. And based on that, we kind of published a lot of papers. The interesting thing is like this media report, which is actually uh, published in American topmost science journal. They kind of cover this whole thing, and they kind of show the value of having a subseasonal forecast for the agriculture. So on that, I'm almost end of my talk, but here I just want to share my experience. So it's very important to share what lesson I learned. Again, go back to the same figure I start with, that this is a hard problem. It's not so easy that we are in kind of having 100% skill and just apply the forecast. So the user sector should understand the limitations. And also as a forecaster, I was thinking, can we improve the skill using a kind of a AI/ML technique? And also understand like all the forecast we kind of generated is very typical three category forecast. That means below average, above average. But that doesn't make more sense. Rather, if you give a forecast of probability of accidents, that means probability of having this kind of rainfall is this, or less rainfall is this. That make more sense. And also, instead of just a total rainfall or seasonal rainfall, you need to make a lot of tailored products like forecast of active or break spell, forecast of rainy season start, onset, or withdrawal. And also, we learned from our experience that we need to work like side by side with the agriculturist and climatologist to make those advisory. Now, based on all those learning, I I just want to show a little like ongoing advancement at NOAA, what I'm doing. So I was a part of a project which is called FuseNet, which is the famine early warning system for Africa, Latin America, and Southwest Asia, mostly Afghanistan. So, and this project is funded by USAID and NOAA and others. So we try to make a real-time forecast, but in seasonal and monthly time scale. And I use all different kind of machine learning advanced method to make a real-time web page. And I just make this QR code so you can actually scan it from your mobile right now to see the page. On that page, we are actually giving the three category forecast. At the same time, we're also giving probability of non-exceeding 20th percentile. That means the lower end of your distribution or probability of less rainfall, very less. And also we are giving probability of very high rainfall, which is highest, like exceeding 80th percentile, which make more sense on the early warning system. And we also keep that the skill maps real time. So every time you use a forecast, you can go different skill maps to see. But this web page is not for the farmers. This web page for the forecasters or who work with the stakeholders to understand the capability of the forecast, and then they translate to the local scale. So this is something I'm talking about. Like this is the project funded by this product, and it started from last month. It's a very big project all over the world, and they are like slowly expanding their region uh, using that USAID funding. And it's established in 1985. It's like very old project. So what is the novelty of this product when I make it? The first novelty is like this product is very high resolution product. Mostly the product available for seasonal and sub-seasonal scale uh, for different websites like NOAA or ECMWF and others. They are kind of 1 degree scale, 1 degree grid, which is almost 110 kilometers apart from each one focus to other focus. But this is kind of a 30-kilometer resolution thing. So it's a very high resolution forecast. We also have probability of lowest and highest. We also use a tool to make the forecast, which I developed 2 years back, so that it's reproducible. So that means anytime anybody can make this forecast who know a little bit of climate forecast science, so that we are not tuning anything. So it's very open. And this is like the steps, a lot of technical things. Again, I'm not going to show that, but I want to show one interesting thing. But before that, this is like the method I use. It's called extended probability of extreme learning machine. Again, a lot of technical things, but here the inputs are climate model forecast, and using this architecture of the machine learning, we produce the full distribution. So using all those things, I was thinking like, okay, and this is the tool again. Sorry, I just skipping this slide. So this is the tool I developed to make the forecast. And this tool is also featured recently on S2S project newsletter. So all over the world, people start using that tool because this tool is not black box. It's a very open glass box. People understand what they are doing, very well documented, and all the method we have implemented is actually like with the whole Python era, people can do any kind of machine learning. But the biggest problem is like using machine learning in a climate data is not so straightforward. So you have to make such a way that it work like a climate data uh, uh, platform. So we work a lot of lot of different aspect. Or also we add a little bit of parallel computing. That means uh, when you calculate for whole grid, whole world, it take forever if you don't have a higher GPU or high quality computer. But the way we make that tool that it can be calculated parallel. Anyway, so this is like on the tool. But what I'm trying to say here, like while we making this forecast, and I was thinking about again the extremes, again this the application of the forecast, and after all this thing, I was like looking at the website and one day and playing and look back on August 2022. Although this website is making for this year, but we also make all the retroactive forecast from 2022. And thinking about this Pakistan flood in August 2022, and I was thinking like, okay, so what was the forecast? So this is the forecast in the May start, and this is the probability of exceeding 80th percentile. And you can see the exact place if you are familiar with the August flood in Pakistan. This is the place they got the lot of rainfall. And this is at the same time I also pull the skill map, and this is like one skill map called RPSS, which is very popularly used in probabilistic forecast. And it's not only the giving the dominant probability, we also have the confidence of the probability because the skill score are really high there. Then I was looking to the June forecast. The June forecast is not as high as the May, but it still have that, the same region, the forecast, and having the same skill. Now looking at the July, it's like huge. Yeah. Okay. I'll come back, but just I'm almost end. So based on that, we found like okay, so this kind of new method has also captured the extreme rainfall, and this is the April initial condition forecast for this year monsoon with the skill map. And on that note, I say thank you.
Thank you, Dr. Nachiketa. As expected, his wonderful presentations where you have detailed uh, what has happened in India and Bangladesh, your model, and also you have shown, in Latin America, sub-Saharan. So, in the beginning, we just mentioned that the main objective of this kind of webinar is that how this kind of pilot studies can give the strength, in South Asia and other places to. You said it's a hard problem. Yeah, it's a hard problem, but we are getting the confidence that based on that, whenever we are visiting the farmers in this region, we have seen that first week forecast they have used, but second week they are totally helpless and crops are getting damaged. But your presentation is, we are now getting the confidence that it's may not be very far away that with all these technologies and machine learning, what you have now will get. So we are, the next part is the discussion. And today we are very happy that a number of international people who are working exclusively on the agriculture material refining fronts will be asking them their comments. First of all, Roger Stone, who is the president of Commission of Agriculture. Now he is a very influential post in WMO. So I'll be requesting Roger, what is your take up and what exactly your advice that how we look this subject and how we can do better in this kind of areas. Over to Raya.
Well, thank you, and thank you for that excellent presentation. I was impressed with the number of features there. One is the recognition of the probability of exceedance, for example, that farmers and others readily understand, compared to the more detailed tercile breakdown or probability of being in the top 20% or 10%. Those little steps are very important in making contact with the users, whether they're in the meteorological departments or with the farmers and so on. The other point, it's very interesting. I've found that farmers and others are very keen to use sub-seasonal forecasts. I mean, 2 to 3 weeks, in the 2 to 3 week range. That seems to be a critical period for their decision making. We've been concentrating on seasonal forecasting, or I have for 30 years, in Australia and South Africa and other places, Vietnam and so on. But the 2 to 3 week period seems to have been a critical gap that we're only now starting to solve. I think that's a key message, that we have to focus on the farmers' decision periods rather than the periods we want to focus on. So that's a similar gap. We find that with farmers in Australia, for example. They're very keen to know the issues associated with, or the forecast for 2 to 3 weeks out. It's been a problem. So that's been my only question then, if I can, Nabansu, then, if I might. And that is, are these 2 to 3 week sort of sub-seasonal forecasts for Bihar and so on really dependent on the MJO? I missed that. It seems like the MJO is particularly critical, and the strength of the MJO and the timing of the MJO and so on for those sort of sub-seasonal forecasts. Is that correct? I wondered if you could elaborate on that a little bit. Thanks, Nachiketa. Thank you.
Thanks, Roger. Yeah. So we used to use that term called forecast of opportunity on subseasonal and seasonal scale. So not every time you have like a very strong forecast. So as I show from the beginning, the predictability depends on this large scale circulation. And subseasonal scale MGO, especially on the Indian subcontinent or the tropical band, is a huge phenomenon. And we are lucky because in 2018 the MGO was so strong that we get that information from the CFS version 2. So before even looking at the precipitation or temperature forecast, we first look at the MGO scale. And based on that, we are confident. So yes, so MGO is like a driver on that scale.
Okay.
And I also want to paste that link of the forecast in this chat for the attendees here. And just one thing, it comes to my mind, some of my colleagues right now, he's actually in Climate Hazard Center at University of Santa Barbara, and right now he's actually in southern part of India working with farmer, and he asked me why this part of India got a lot of rainfall right now, because it's happened to be very dry. And I was looking at the forecast at the February start, and I see that this forecast, which I make it, is actually captured this above normal in the southern part, which is phenomenal. I was like, wow, because mostly what happened whenever we make a seasonal forecast, we're looking at either rainy season, either monsoon or whatever. So that's kind of, I see the power of using a nonlinear method like machine learning, which can bring those kind of anomalous scale instead of just using a linear bias correction. Anyway, Roger, I don't want to distract you, but just suddenly it comes to my mind. I just want to share.
Excellent. Thank you. Thanks again. Thank you. Yeah. Thanks, Nabad.
Thank you, Roger. We have with us Sue from South Africa, who is also associated with number of programs with WM. Over to Sue. I think we are missing Sue. Now it's over to Samsul Huda from Australia. Dr. Samsul Huda.
Yeah, thank you, Dr. Nachiketa Chattopadhyay, and thanks to Dr. Acharya. One thing just want to know, you have, I'm sure you may have, but I am not aware, I still have a continuing projects in Qatar, the Middle East region. on food security. The next few years will continue on. Now, do you have something particular? I was interested about your temperature forecast in the fish. Because we do in the plant physiology, like plant aspect, I understand, but I didn't work on the fish eye aspect. But the current project that I'm dealing with is very much integral. And what sorts of collaboration through you, through NOAA or Colombia, do you have in that region? Let's say, for example, Qatar or neighboring countries in the Middle East. What was the forecast in the seasonal climate forecast region? Temperature mainly I'm thinking about. There's not much rain, temperature, dust storm, that's what I'm after. If you have answered, that's fine. Otherwise, I can get in touch with afterwards. That's my critical intent of the next 3-4 years.
Sure. I'll be happy. I'll be happy to collaborate. Just let you know, like for the Bangladesh project, we work with WFP, World Fish Program, very closely, and they have a pilot study. They collect all the, on-site data. So that's what we make all those, pond versus seasonal mean temperature relationship, and we make it. Right now, I was mostly connected in that part of the region you work on the Afghanistan through this FuseNet, and they are mostly on the drought, not for the temperature. But I love to talk more about that, and happy to help if I can.
Thank you. I need to go for another meeting. Sorry. Thank you very much. Really enjoyed the presentation. I'll get in touch with you later on. Thanks, Dr. I need to go for another thing. Thank you. Bye.
Thank you, Dr. Huda. Now it's over to Andrea. Andrea from Argentina. Andrea, you have anything to ask Dr. Nachiketa?
Thank you, Navansu. Congratulations, Dr. Nachiketa. I am asking for you about forecasts on seasonal scale from phenomena quite different from flood to drought, with time scale very different. What about the precision?
Like, if I understand, like, you want to say like because the flood has a different time scale and drought is a different time scale. So how you? So the forecast I'm talking about the end, which I prepare for NOAA. This is not like particularly looking at drought index like XPI or SPEI. It's not like that kind of focus. Rather, it's a seasonal focus for the mean temperature and mean rainfall. And while you are giving this probability of exceeding 80th percentile, probability of non-exceeding to 80th percentile, that give that forecaster on that region to get an idea like how, like when you say the above normal rainfall, what is the above normal look like? Above normal can be anything greater than 33 percentile, right? Because we have 3 categories. So you can just make 1/3 of them. So 40th percentage of is also above normal. To giving the probability of the 80th percentile of the other side or 20th percentile other side, to giving that idea. It's not a forecast for the drought itself. Rather, it's a forecast which can tailor to the drought. And FuseNet mostly interested on the drought. But we said like, this is the first product. We're thinking to giving the same product like SPEI, which combines temperature and rainfall and soil moisture for the future. And at the time, the precision is a very important, as you said. And that time we can think about. But I really appreciate your feedback.
Thank you. Excellent.
Thank you, Andrea. Now we have a galaxy of scientists in India and in South Asia. So I will just request them. First, Dr. Mohanty, US Mohanty.
So very good morning, and I congratulate Nachiketa for a very interesting presentation and making use of all this for application, because as we know that seasonal forecast is or even sub-seasonal forecast 2 to 3 weeks is extremely difficult as we go for accuracy, but but it is a utility and applicability is more important, and that is what when people learn the things, because it is very much needed for the farming community. So therefore, I feel that it is a good way of approach to work with farmers, and I want to know, Dr. Nachiketa, for the aquaculture, the 30 and 32, it will be the water temperature. Correct?
It's a pond temperature, yes.
Yeah. So how to get, after getting, suppose the atmospheric temperature, how you converting to pond temperature? Pond will be very small scale, actually, with a few meters. So how you are converting that from air temperature to that of the water temperature?
Thank you, sir. And I just much appreciate you because I am sitting here because of you. You give me the opportunity to work and I did my PhD with you. So thank you.
Excellent work. You are doing very excellent work and new approach of AIML. I think these things can be gradually improved because when we started medium range forecast in 1993-94, that time the remark from the India meteorological community that send it to garbage. It is not good. But now all the forecast, even tropical cyclone, we are forecasting about 7 days comfortably, and it is working. So things will improve. And once you start, you get the feedback, go on improving. So that's why I feel that it is a very good job you are doing. And continuing that, that's an excellent thing. And I think it will definitely improve the AIML.
Yeah, sure. And just go back to your answer, your question is like, yeah, I show one slide, I may send the paper to you. So we kind of having a very empirical relationship between the pond temperature over Sylhet and Khulna and the air temperature of the nearby station by BMD. And we make a very linear fit on that. We're not 100% confident that that is the thing, but we get something because it's, as you said, it's very hard. It's not only like temperature based on so many different phenomena on that area, but we just use a very linear combination, a linear relationship between both. But it could be done in a very sophisticated way. And another thing is like getting pond
But
temperature.
it worked and they got benefit. That is more important.
And also like the data over pond temperatures is not something we can get it for 10 years. We just get it for 1 year. And whatever the data we have.
Even if you tell a month in advance or a week in advance, they can catch the fish and sell it instead of dying in the pond or something.
Exactly. Yeah. Thank you, sir.
So now I'm requesting Ramanna Rao, sir. Sir, can you just give your views onto that? Over to Dr.
Actually, I congratulate Dr. Nachiketa Acharya for the excellent work he is doing, and he has opened up our vision with his presentation today. What is more important is how to translate this forecast into action plan. That's where we have to focus. And another thing I could see is this year, the India Meteorological Department has come out with a long range forecast with greater resolution. First time I could see. And what is the resolution of the, if we can improve the resolution of the sub-seasonal forecast, it will provide an opportunity to develop some kind of preparedness among the people, and medium range forecast can be translated into action plan. This is how we should try to evolve a system of using from long range forecast to short range forecast, and for the benefit of the farming community. And another thing I am greatly impressed with, the way in which the forecast information can be used for inland fisheries. This is an area where India has to focus because we have a lot of potential for developing fisheries and in India and to compensate for nutritional deficiencies. Thank you, Dr. Acharya. It's a great pleasure to hear to you, and we would like to have more such opportunities in future. Thank you.
Thank you, Dr. Rao. I think you are muted, Dr. Chattopadhyay. You are muted.
Yeah, thank you. We have a guest from Myanmar who are trying to develop the agrometeorology. So Hansu is with us. Hansu, can you share anything from your side?
Thank you, sir. Now in Myanmar, we are preparing the some data to launch the agroclimatic advisory services web portal. Near future, we will launch that web portal and we upload the agrometeorological focus and also for the agro advisory for farmer. We have plan. Yes. Thank you, sir.
Thank you. Dr. Sheikh.
It is audible?
Yes.
Hello. Congratulations,
Yes,
Dr. Nachiketa Acharya, for nice presentation and giving a good information of the sub-seasonal forecast for the benefit of the particularly the fish farmer in the Bangladesh and in the Indian subcontinent of the Bihar. The important thing is the how to transfer this information to the farmers and how they utilize that is there that Brahman Rao Sahab has already mentioned about it. And the another aspect is as the Roser has already mentioned about the accuracy and the how to improve that accuracy for the forecast. For agriculture, in particular in India, the rain-fed agriculture area is most important, and they are very anomaly in the rain-fed agriculture. The rainfall is very high, and in that dryland area or the rain-fed area, how the Bihar model can be applicable, and if it is applicable, what are the requirement and how to the IMD and the then Council of Agriculture can proceed. Thank you very much.
So, Nachiketa, will you react to that?
Yeah, like the reaction is like, again, that's not my expertise. So how to disseminate that focus, and that's your expertise and all of you. So I love to work with you to make it, but I could not add value on that.
Okay. Thank you.
Dr. GGSN Rao.
Okay. Thank you, Dr. Acharya. Am I audible?
Hello? Yes.
Okay.
Yes, you are.
Good. It's good. I had two questions to Dr. Acharya. One is that I could see there are many entrepreneurs available in the world that they give the forecast. To the and their area is a forecast is also about 3 kilometers or 4 kilometers. They claim it, and that is available freely. Or even if you go to any apps, weather apps, so that information is readily available, and they can easily get their forecast to their particular region. So in what way it is different? Your forecast, of course, you are giving a seasonal forecast, and these people are giving for next 2 days or 3 days or maybe current day forecast. So in what way your the technology is different from their technology? And this second part is because farmers wanted to know what is going to happen in the next 5 days or 6 days over his region, say maybe 3 kilometers or 5 kilometers distance. Say, but if you give a seasonal forecast for the whole of at a district level or a state level, it has its limitations. The application of that is some limitation, because it is highly variable, because even within Hyderabad, I know I'm staying, say, under 2 kilometers away from my town. There's a heavy rain, and there's no rain in my locality. So like that, the farmer want to know what is the accuracy first, and the second is that is it going to have the forecast, is interested forecast of his region. The second part is just you said that absolutely India is not experiencing any summer season this time. Total country is having a lot of clouding, and the temperatures are very low. I mean very low, and even floods are occurring. One of my friend, Dr. Prasad was telling, floods are occurring even in Telangana and all the Telugu speaking states, and also in the southern parts. You said you already indicated this information in your February forecast. Has IMD taken the cognizance of your forecast? These two questions I want. Thank you.
Okay, that's a really good feedback. I'll start with. I think there's a three question. So the first question is like, what's the difference between the weather apps forecast and my focus?
Yeah.
As you already mentioned, the weather apps is for 3 days, 4 days forecast and high resolution, and my one is like sub-seasonal, seasonal. That's the difference. Another difference I would say that the weather apps, they use either IMD's short range forecast or they run some kind of numerical weather prediction. Mostly WRF based forecast. But the biggest problem is those forecasts doesn't communicate the uncertainty of the forecast. They just give the forecast and people look at it and believe it 100%. It doesn't communicate the limitation. For example, in my case, in website, I communicate the scale. For example, what I show for the Pakistan flood, I also looking at the skill map, the particular region, whether I give the high probability, whether it comes at the skill map or not, because that is important to communicate the forecast. So I think that should be when you communicate some kind of forecast, you should also communicate the limitation. Second question you have is about what you said. The second one, I
It's
remember
about
the last one, the Southern
yeah,
India. I remember.
floods and absolutely there is no summer in India nowadays. Absolutely, whole of this April and almost I mean just a part of April and whole of the from mid-April to even till now, we are getting a lot of rains throughout India. And you
Yeah.
said
So
that you only give this forecast in sometime in February. The
yeah, I just
conditions.
want to show this before I say anything. Just a moment. You can see. Can you see that focus page?
Okay.
So
Probabilistic
if
prediction.
I come global to let's say South Asia, it will be like, and this is like February issue 2023, March, April, May, and you can see the probability of above. And if you just change it to the probability of highest 20th percentile, you can see this thing. So first of all, I started communicating this forecast with IMD just 2 weeks back at of forum, because it's like it take a lot of time to make a forecast and then a lot of time to convince and give the faith. So I don't want to just make the forecast and send everybody. So in the last SASCOF, South Asian Climate Forum, I show the forecast and from then IMD start using it. So which is in month of April, not in February. So I hope in future they are going to look at my website and make some kind of decision based on my forecast.
Acharya, just I want to say, I mean, what are the reasons why? I mean, absolutely, you're feeling the monsoonic, I mean, dipole in the just in the Indian oceans. So this we'll never see, in this we see only during the monsoon time. This is not a monsoon time. Monsoon has not yet started. But for the 10 days or 15 days, we are seeing the dipole and continuously clouding over the equator and is moving towards the, the southwesterly movement. What is the reason why it is like that?
Interesting question, and I not completely agree with you that India doesn't have summer. If you look at the eastern part of India, especially Bihar, West Bengal, that part, it was like heat wave. Last 2 weeks back, also the temperature is like 42 degrees Celsius. So especially the southern part get the rain this time, not every part of the India.
Even Rajasthan has highly cloudy and it received rains. Rajasthan,
Yeah, and
yeah,
Delhi also, like I just saw
Gujarat,
like
Gujarat,
2 days
Delhi,
back.
yeah, yeah,
Yeah,
Maharashtra,
yeah,
yeah.
yeah. So one of the like these are the thing, like the reason behind that, as you said, the convective cloud in the tropics, those and Indian Ocean dipole, as you mentioned, is positive, but there is a like IOD impact of monsoon is really like it's not started yet. Somewhere you can see in the mid of June or July to start reflecting on the monsoon. And IoT is a phenomena which impact the seasonal scale, not the day-to-day scale. So I feel like it's more of the atmosphere or weather phenomena than the seasonal phenomena. And again, I'm not an atmospheric scientist. I should not give the answer. As I said, I'm climate data scientist, so you should talk with the colleagues from IoT.
Okay. Thank you. Thank
So
you.
now,
Thank you, Dr. Ashok.
okay, now it's over to Dr. KK Singh. Dr. Yeah.
Yes, very good morning, Dr. Chattopadhyay. First of all, thanks for organizing such bold lecture from Dr. Nachiketa, and thanks to Dr. Nachiketa. Just looking at the comments from Indian scientists, so whatever you have told about the experience gained under Bihar pilot program and in other parts of the world also what are doing. So how to translate this, how to implement this. So, this Association of Agrometeorologists organize the event every year as a form of annual event sometime. And then we also have the agro-advisory service running from, in collaboration with ICR, agriculture setup running through the district level. So means what I want to say, we have the experts in the country at district level. And the one most critical component of the successful implementation of Bihar pilot program was co-production system for information generation. Means involvement of the farmers right from the beginning, as you mentioned also, through the FF, Farmer Field School. So here we have the experts at district level. So if those experts are able to understand the language, what you try to communicate to this galaxy of scientists or climate information, total climate information spectrum, what you try to make us understand. If those experts, youngsters sitting at district level, they understand and they are in a position where they are interacting regularly with the farming community. And because it requires the farming community to be involved since the beginning of the forecast is disseminated, before forecast starts is disseminated to them. So this is a very, this will be a unique contribution from your side. And we are thinking of organizing pre-conference training module. It may be 2 days, it may be 3 days, probably in the next year, January, February. So we would like such experts to be here, and we can invite all those around 90 to 100 in number, the young scientists, to have this kind of experience, gain this kind of experience, and start working in this direction, what we collectively did in Bihar. So this is my very strong suggestion for this community, and Dr. Chattopadhyay, I request how to make it happening. Thank you very much.
I just want to add, as you know, sir, that without you, the Bihar project cannot be, finished or started yet. So you're the backbone, and because of you, we connected that whole agro team and SAU and the farmer. So we kind of, jump on your boat. So thank you very much for helping us. And I totally agree with you. And while we are in the field school, and you see that the young professionals from the NGOs and the agriculture universities, they understand those terms much better way. So I'll love to part of the conference you talking about. So yeah, I'm just looking forward whenever it will be there. Just give me 2 months late so that I can plan according to that. So I'll be happy to do that. Thank you.
Yeah, Dr. Singh, thank you very much. Dr. Nachiketa, you said your product is being used by Bangladesh. A number of, important people from Bangladesh, they have joined. So I'll be asking them what is their feeling. So I'll start with Kamrul. Dr. Kamrul, floor is with you. Kamrul from BMD, Bangladesh Meteorology Department. Okay.
Thank you, Dr. Nobangshu, and again, thank you, Dr. Nachiketa. With his initiative, seasonal forecast in Bangladesh. So we are always acknowledging, and it is still in operational. But Dr. Nachiketa, you know that there is some drawbacks of that next-gen forecast system. And recently, Bangladesh also introduced subseasonal forecast with the help of DAE. And that tool also have some has some difficulties. That means they are using linear regression only, and known machine learning is not using. So I think along with existing tool, we should go for XCAS also. And then we can compare that, that means forecast from different tools. That is one question from my side that about hindcast. Hindcast is 1993 to 2016 you are using. So we think that it should be updated up to 2022. And is any effect of that, that is length of the hindcast on the forecast?
So first of all, thank you very much, because we started working 2017, and it's not easy to working with the med department and convince them and use a new method. Really appreciate your foreseeing your overall thinking how to upgrade the BMD's focus. And I think you're the only person who talked about all those things back in 2017. So I appreciate you. And also to just mention the next gen focus, which is implemented in 2019 and developed in 2018, is almost 5 years back. So obviously you need to update. And the method I use right now is machine learning basis. I'm looking forward to implement this thing in BMD through the forum of SASCOF or SAFOM. And obviously the tool I develop, XCAS, is more capable and more, it's not a black box like other, I don't want to name the other tool, but it's not a black box. Yes. And the question is, like, you're talking about a very technical question, and I want to reply here in a general language. So the hindcast is the first forecast. So wherever we do any kind of improvement in the forecast, we train our model in a past forecast. Based on the past forecast, we understand the amount of error, and we use that factor to multiply the real-time forecast to improve it. Now your question is why you are using just 1993, 2016, why not up to 2022? So the modeling system I use, it is actually called Copernicus Climate Model System, which is hosted by ECMWF, and they are kind of fixed on their hindcast. After 2016, although they started making forecasts, but there is a gap. Not all models start forecasts from 2017. There's a lot of models we start forecast from 2020. Some of the models start maybe 2017, but they miss a couple of the months. So there's a lot of gaps in the, if we want to append the forecast after 2017 to 2023, that 5 years, you can see a lot of gaps on the data. And as you know, like statistics doesn't like the gaps, any statistical model. So that is kind of a limitation. And I talk with the person, his name is Douglas Reyes in Personal Computing Center, and talking about why not you just, just run a couple of more years. And they are kind of said that, we are trying to use the new climatology and we don't want to run more, because every time you change the version, you need to run the past forecast, which is computationally very huge. As you know, as a modeler, if you want to go back and run for all grid and all things. So I think there's some kind of resource limitation right now, but I hope with some kind of new funding they are talking about right now with the destination Earth in ECMWF, they might be fill that gap so that we'll have like 5 more years of hindcast. Again, thank you very much for this question.
Thank you.
Anybody from Bangladesh want to share? Anybody from Bangladesh? If not, now over to Binay Segal.
Yeah, thank you, Dr. Navasu. Am I audible?
Yes, you are audible.
Okay, it was good to listen to Dr. Acharya, and I'm really happy that we have been making a lot of progress in doing seasonal to sub-seasonal forecasting, both in terms of time as well as in terms of gridded application, especially for agriculture, because bringing down the forecast from a 1 degree to 0.25 degree is really good. But still, from agricultural point of view, our requirement have not yet met. Our requirement still goes to a much finer scale. Like if we are doing a work for Pradhan Mantri Fasal Bima Yojana, which is a crop insurance scheme, where the insurance unit is hardly a group of villages. So we need something, a graded forecast at the order of at least 5 kilometer or below. As well as they need to do their risk analysis for coming for a month or so at a sub-seasonal scale. So, so still we have made some progress, but we have a long way to go yet. If we have to really make a very good applications at the ground level, which impacts the farmer decision. Another important thing is that we need to develop system. This is my suggestion. Actually, I'm not questioning on anything. My suggestion is that we have to develop good system for agricultural application. We need to bring in a lot of other data sets together along with these forecasts, especially of extreme events. Like if I have to do a drought forecast, drought for a agriculture scientist is not a precipitation forecast or a SPI forecast. It depends on what is the water availability or irrigation available in the ground, what type of crop it is, and what stage it is. So we need to, like we are doing some work on doing that kind of work, where weather forecast, bringing in satellite-based crop condition assessment, soil moisture already observed from different satellite sensors, as well as composite drought index, which is the current situation that is to be used at a very fine scale of something like 1 kilometer. Though our results, we have not yet made any great significant achievement in that, but we are trying to understand those things. So I would request that if Dr. Acharya is interested on such kind of aspects, bringing his knowledge and skills of forecasting to some agricultural application, then in Indian Council for Agriculture Research, different centers and Indian Agriculture Research Institutes, we can also join hand in some of the opportunities which comes involving, of course, IMD into the system. So this is my some observations, and thanks to SAFM for organizing such a event and making us aware about how the things are improving and where the things are going in terms of achieving new benchmarks in doing a seasonal to sub-seasonal forecasting. Thank you, Dr. Nawasu.
Thank you,
Thank
Dr.
you,
Sehgal.
Dr. Sehgal. Yeah, Nachiketa, over to you.
Yeah, I must say that I'm a big fan of your work since my days in IT Delhi. So thank you for your comments. Yes, I think the whatever I develop right now, either you can say is like a very micro scale, like a pond select, or bigger scale like global product. So it's very tough to actually attain all those demands. As you said, like it's not only the SPI or rainfall focus, you need more. And on the FuseNet forecast with my colleague Mike Hobbins, we're actually working exactly a composite index for drought and agriculture and soil moisture, but that's just for one particular area, because as you know, the data availability is the biggest thing we cannot make for a whole globe. So I kind of putting my hand on that, just not only SPI or SPI, but I'll be happy to be collaborate with you on that. If I can actually added some value on whatever I see here and your institute is working, I'll be happy to be part. Thank you.
Thank you very much. We'll talk.
Thank you very
personally
much. Actually, yeah, there is a good discussion is going on. Now, I have seen that number of persons, scientists who are exactly and in operation, they are working on the in agriculture field, particularly in agrometeorology. They are with us. I'm just requesting them if anybody wants to ask anything from Nachiketa, because this is a rare opportunity to ask such a person who is very much expert into the field, and this is our future project also. So it's now open to all, the field unit station. They can raise the question. Over.
I have one point to say here, share with you. We are always talking of farmers and how to take the forecast to farmers. The other important aspect is how to sensitize the various departments involved in helping the farming community in timely operations like input management, resource management. I think we have to involve them as stakeholders in these forecasts. And another important thing is beginning of issue of forecast is very important. Reliability and accuracy, resolution will come with progress of time. Good beginning is always good. So let us see how we can take this forecast to other agencies connected with input management, resource management, water management, and whether any policy regulation is required for water management, because this is particularly this year, there is deficit rainfall during southwest monsoon, and also rainfall is likely to be deficit from October to December in several parts of India, except in Tamil Nadu and some southern pockets. So this is a very important aspect, and we should look into how to take this forecast to other agencies also that help the farmers.
Thank you, sir. Now, anybody from Agromet Field Unit in India?
I see Dr. Karthik Chakravarti is his hand.
Yeah, Dr.
Yeah.
Karthik Chakravarti.
Yes, yes. Thank you very much, Dr. Nachiketa, for your very important and informative presentation. You have shown in your presentation Bihar model forecasting system. Do you think that Bihar model forecasting system is applicable for Bangladesh? I think very much similarity, the weather and agricultural condition with Bihar in our Bangladesh. Do you think that Bihar model forecasting system is useful or applicable for Bangladesh?
Yeah, sure. I will let Dr. Chakravarti to reply because we actually build up a proposal based on the Bihar project to the DAE Bangladesh, and after that there is a project. So, Dr. Chakravarti, you can just just summarize what you have done.
Yes.
Yeah, I have already this kind of queries at the end. I'll speak onto that. So okay, I'll just respond to that. Okay. So anybody from Agromet Field Unit?
I see.
Yeah.
Yeah, go ahead.
Yeah,
Sir.
Dapode. Yeah.
Yeah. Good morning to everyone. Dr. Nachiketa, you have given very nice presentation. What exactly we are very fortunate to use the extended range weather forecast from last few years also through IMD, and Dr. Mohanty and his team. He has already developed these products, and we are catering the services. In S2S, what I am looking while operating these products at the in rainfed agriculture, it is very difficult to take a decision on the basis of the seasonal forecast. Sometimes we feel very lucky that we are okay. They gave the very good outlook, but within that jurisdiction, suppose we have the large scale that domain, and in same district, we are taking an example. Even some previous speaker has already raised the issue about the scale and resolution. In same district or village level, farmers are able to know what is happening, because decision making is a very crucial thing. They have the faith on the forecast, and we are only source to give the information on the what is happening in coming days, that is for 10 days 15 days period. If we are able to downscale these products, so we are very happy to share this information within a district, because we are catering the information in similar fashion what we are looking the outlook of that your seasonal forecast. But while we are making in operational mode in same district, we are having the two different features. Some part is also exposing for some kind of rainfall activity, and another part is exactly matching with our forecast. So that discrepancy is happening while we are making in operational mode at the ground, that is at scale is the issue, the resolution is the issue. That is my concern. How can we bridge that gap?
That's a really good question, but that's actually what happened. Like, for example, Bihar, we exactly did the same thing because although Bihar is a state, small state, looking at the global map, but it has so heterogeneity of the drought and flood district, and we actually downscale it using this method called canonical correlation analysis. We downscale it over the district and make the forecast. But that is possible because we have a project and we have a resource. It's not possible to downscale every district based on those kind of method until unless IMD do that kind of things. And the forecast page I shown in my web page, this is for the global products. So I cannot downscale it every district. Rather, this global product is like high resolution, 30 kilometers. So you can get some idea on 30 kilometers resolution, not at the 5 kilometers if you're looking at global map. But downscaling is something really required for this kind of district based forecast, and I agree with that. But that need, as I said, that need IMD's intervention rather than using a global product.
Yes, exactly. Thank you. Thank you.
Mhm.
I have one question, sir,
Yes.
with your kind permission. Very good morning to the galaxy of national and international scientists. Namaste to Dr. Ramana Rao, Dr. Tupapadhyay, A.K. Singh, Sir Mohanty, sir, Vinay Saigal, sir. Sir, my question is to you, Dr. Nachiketa, sir. It was a very wonderful presentation. What is experience regarding the undulating topography? Everybody is talking about the Bihar. That is the plain area. Do you have some experience? And if you have some, what is the critical success rate? Or what is the, I must say, percentage correct of that forecast? I have this question.
Thank you, Dr. Sharma. It was really good. Like, I just want to mention one thing. Whatever I present today is like just like 10% of my work. So I have experience with working in Vietnam and Central Highland, where is a lot of mountains. And I work with the coffee farmer there. So that I will come back on that, what I have done. Also, I was working with, in fact, Bangladesh Met Department. Uh, Bangladesh is not flat everywhere. Like if you look at northeastern part, Sylhet and others, it's very like, or that southeastern part, maybe, yeah, a lot of mountain. So I want to go back a little bit before the seasonal focus, before the weather focused. First, we need a high resolution observation data. That include that information for the topography, right? So while working at Vietnam, while working at BMD, we started from the scratch. We started making the data. Now, Bangladesh Met Department has around 65 station right now. I forgot the full form of National Hydro and Met Society Vietnam. They have like 120 data point, but a lot of problems. Not the station is like always there. They change the place and then the maintenance this and that. So it is a really struggle to get the local features of the rainfall while it is not plain. So we started making a data set which is the merging between station data and satellite data. And the satellite data we use mostly from this CHIRP trip data, which is maintained by Santa Barbara, University of Santa Barbara. So we did a lot of that work first. And especially on the Vietnam, I want to say like Vietnam is a very interesting country because the highland is in the central and the northern part is flat and this and that. And based on that topography, they also kind of specify the crops, like Central Highland only coffee, southern part only rice. So we develop this first high resolution data. Based on the high resolution data, we make all the definition. What is the onset of the rainy season, which is not only based on the rainfall, this is also based on soil moisture. This is also antecedent conditions, sorry, and also like the crop specific. So a lot of work has been done before the seasonal focus. And after that, we did it. Coming back to your question, like, yes, that is a huge impact. And mostly we are dealing with climate model, and climate model is like gridded, as you know, and it's mostly smooth out this topography. You cannot see the difference in, in a Jammu Kashmir or Central Hyderabad, Vietnam or coastal part of India. So having a high resolution observation is the key. And then we use that observation to calibrate the climate model so that it bring the features. And that exactly what we are doing in a couple of the project. Yeah, that's my answer to you. Yeah, that's a very valid point to have it this information.
Thank you, Nachiketa. Now we have with us from Afghanistan, Mr. Najibullah Usmani. Usmani, over to you. I think we could not reach out to Usmani, but now we are almost at the fag end of this today's program. But the most important part, what I mentioned in the beginning, that what is the objective of this webinar? The objective of this webinar is that to hear from the experts and how to implement this kind of initiative in particularly in South Asia. And today Rajar was with us, so even I invited the chief of the WMO, Robert Stefanski, but because of the time gap, they could not join. But he is very much aware that today's lecture will be there. So my points to Nachiketa, I'm coming to the application part. The thing is that now Dr. Shivakumar has joined. Okay, who is the earlier the chief of the WMO and he was World Bank consultant. Now my point is that uh, whatever your knowledge, whatever you have done, how this could you have said that Bangladesh and India it has started, but in Sri Lanka, in Nepal, in Myanmar, they are just looking at us and they said that we want to do this kind of thing. That day I was talking to the Robert Stefanski. Actually, we had a plan called GCREAM, that is Global Center for Excellence, like that. In the GCREAM, we'll be trying that how this kind of scheme, can be implemented in others with a lot of funding issues will be there. So I will be requesting very briefly if you can. I know it's a not a very easy question to answer, but what exactly you think that whatever you have done and what are the experience, we have the knowledge pool, just like Mohanty, Roger Stone, and so many other people are there. How this knowledge pool can be put into one place? What Dr. KK Singh also said, this seminar, what I may be. Ultimately, I know it's a easy task, but we can start the beginning, exploiting your work, your knowledge, like that. Just quick point, you can tell us that how this can be done. In a very broad way in the South Asia involving all the countries, because the countries are very interested. We have make two sensitization program where the Secretary Agriculture Minister was there. They said, you just guide us what exactly we are supposed to do. They said that funding may not be the big issue that they will exploit. So I was just asking you, Nachiketa, that how you can make a holistic plan. Then maybe we can arrange a very small group meeting where we can see that what could be the feasibility and how can we start with this. So I know it's not a very easy question answered very this kind of question, but you can give a broad way. Over to you.
Yeah, sure. Thank you. And as you know, like the biggest limitation of this kind of things is like the funding. If the funding is not the issue, then I can tell what to do. It's like obviously you need a platform, whether it's SASCOP or SAFOM, which actually maintain this instead of just individual scientists doing this, you know, consultancy kind of things. And then the first thing is like what I see in my 15 years of career, like initially we have a lot of energy and then the energy come down. And the reason behind energy come down, because as you all know, nothing is free in the world. So while you are like requesting some people to just give your time without anything, they start with something and then go back. So funding needed, money needed. We need our time, we need our money, first of all. Once we give the money, we are committed. And then we have a solid date, like a plan, 6 months, not more than that. Because if you make a more than 6 months, again, the whole energy come down. And then I think like just one or couple of meetings to start with, the way you started at DAE in Bangladesh, talking with the Med department, talking with the sectors, because at the end of the day, this project will end and I can go back to US, but that project will still continue through the Med department, through the DAE. So the biggest thing is like the capacity building. What we exactly done with the BMD. I left IRI almost 2 years back, but BMD is still working on that next gen. So we spend a lot of time to teach a person like Kamrul, who is like the best in the department, and then he teaches others. So it's going on that way. So I think capacity building is the key if we have funding and committed, time. Thank you. And I see Kamrul raise his hand.
Yeah, Dr. Kamrul, you want to say something?
Yes, actually, related to this, last SASCOF, there was one discussion, it raised by Dr. Mohapatra, that how we can use extended range forecast or different timescales forecast along with seasonal forecast. So I think it is the best time, or it is the proper time to introduce other timescale forecast along with seasonal forecast. So I think we should go for that. Thank you.
Yeah, just a quick comment, Nachiketa, that in SAFOM and SAMA, we are, growing very step by step, The main advantage is that, we have a huge knowledge pool who has, worked for 30 years, 40 years, on agriculture field or like that. And also we got some kind of indication that funding is also possible, but how to possible that we make it. But nevertheless, we will be trying, because whatever the today we got the kind of information, and we just crystallize all these things and try to make a project with you, and let us see in future how a small obstacle can be removed, and ultimately the farmers in this kind, because you know better that climate change, climate variability will more and more in future, and successful forecast will be very required for them. That's why all the government is trying to invest, but hopefully this will be, and then only the success of SAFOM and SAMA will be granted like that. So if anybody has any further comments, otherwise we will close here. Anybody who want to make any kind of comments who has been left out? If not, again, once again, thank you, Nachiketa, for sparing very valuable time and very good work with us. We learned a lot from you, and all we will be now today energized, actually, what you have done and you are doing. Dr. Mohanty, your guru, has already mentioned, in aqua, particularly in fishery, is very difficult task, I know, but you have showed it is possible. So if fishery is possible, then we feel that other crops and livestock will be possible. So with this great hope, once again, thank you to you and all this delegates, participants who joined here and shared their, very valuable knowledge to all of us. Once again, thank you all. Just a last announcement is that we will be organizing another important workshop next Saturday, that is on 13th, that is SAMA and SAFOM, that is basically on long range forecast. And this long range forecast, what SASCOF has issued, and you are also the part of this, and maybe IMD will be presenting from IMD side to the whole South Asia. And we have requested the ground realities who are working in all the 9 countries, because the forecast is available with them, what exactly they are thinking, whether it is below normal rainfall, above normal rainfall, normal, what they are supposed to do, what kind of contingent planning. And so next, Saturday, so I am just inviting all of you. I will invite through email also. That will be also very interesting. On this application part, will be more discussed, and Dr. Ramana Rao, he has also mentioned somewhere that we have to translate this kind of forecast into this application part in South Asia, most advanced countries, India, Bangladesh, and also Myanmar, Afghanistan. So with this note, once again, thank you to all of you. And now we close it.
And also, I want to thank you, Dr. Chattopadhyay, to giving me this opportunity. And I was really like, it's not only you guys are energetic, I also be so energetic. And it's tough for me to count on and sleep. It's midnight here. So I was thinking like, how can I sleep today? But I'm sure I will have a very good dream. So thank you.
Okay,
Bye
thank
for
you
now.
very much. Thank you.
Thank you.
Thank you. Thank you, everyone.
Thank you.
Thank you, sir.
Thank you, Andrea.
Thank you. Thank you, Navansu. Very well organized.